So starting off today, reviewing on how to evaluate a function. To evaluate a function simply means you are going to take a number, which we refer to as the input value, which is labeled there as x. That's the one that we put in there. What's the other word we use to refer to as x? It begins with a D. Your domain. So you place that value into the function. The function makes some magic happen, and then it gives you your outputs, also known as your y value or your range. So then a couple of reminders. F of x right here means that is your function, so it's function of x. So function of x, that just simply means you take an x value, plug it into the function, it gives you an answer. Because it's a function of x, you can't plug in, say, an n. You can't plug in an a. It's got to be an x because it's a function of x. So then f of 1 represents the value of the function at x equals 1. So wherever that x value is, you're just looking for your function at that point in time. So the way our functions work, we start with our x values. We plug it in for x of the equation. So if I'm looking at the absolute value of x, first thing I would do there is I'd plug in a -2 because that's my first input value I'm looking at. And what would we get? What's the absolute value of 2? 2. The absolute value just makes that value turn positive. So now plug in a -1. And I'll get a 1. Plug in 0, you get a 0. Plug in +1, and you still get +1. Plug in +2, you still get a +2. So our absolute value turns those are all positive. The absolute value of x is our function. Now we can look at it off of the graph too. You could have gotten those points looking off of the graph. Thank you. So like if I'm looking for x is -2, I would go to where x is -2 on the graph and find where my function is. So it's right here at +2. So that's the other way we could look at it for the graph. So let's say I wanted to look where x was 0. I would go to where x is 0, find where the graph is. It happens to be right there at the origin, so the value of the graph is at 0. So you can either plug it into the equation. You can look at your graph. If you already have a table filled in, you can just simply look at your table. So they want us to state the domain for, the domain for h of t is t squared minus 1 is -2 to 0. State the range. So in order to find the range, I'm going to first plug -2 into my function, because that's my most left value of my domain. So -2 squared, what does that give us? 4, good job. 4 minus 1 gives me a 3. So at -2, my function's at 3. I'm then also going to plug in 0. So 0 squared minus 1. Well, 0 squared gives us 0. Minus 1 gives us -1. So what's our lowest range value there? The -1. And it's going to go up to 3. So that's why you want to plug both of them in. You plug in both extremes, so the beginning and the last number. Figure out what you get. That's going to be your range. Now this one happened to work out that you had to switch the values around so that you could go least to greatest. Sometimes it actually stays in the order as the domain does. So number 2, given p equals those 4 points, they want us to find p of -1. So again, this -1 is where x would be. That is in the x spot there. So let's go to where x is negative 1. The other value in our point is positive 1. So p of negative 1 equals positive 1. That point's telling you they did all the work. They took negative 1, they already plugged it into the function, they got positive 1 as the answer. So the work was done for you, all you had to do was find it. 3, we're given g of x equals negative x squared. They want us to find g of negative 2, so that tells us we're just plugging in a negative 2. So we've got this negative sign here in front of the x squared. That's still going to be hanging out there in front of your negative 2 as you square it. So what is negative 2 squared? Positive 4. And then because of this negative sign out in front of our parentheses, it turns it into negative 4. So g of negative 2 is negative 4. So they want us to find f of 0 for 4. That means we're plugging a 0 in for our x there. So 3 times 0, 0 plus 5. So f of 0 equals 5. Put your input value in, get an output value. Okay, so now we have a graph here. They want us to find 3 different values, k of 1, k of 0, and k of negative 1. So again, those are our x values. So k of 1, let's go to where x is a 1. So here's where x is 1. My graph is up here at 1. My range value, my output value would be a 1. So we'll go next time. Now we want k of 0. So we're going to go to where x is 0, which is right here. Find my graph up here at 1 also. And then the last one, k of negative 1. So I'm going to go to where x is negative 1. Does that open circle value count? No, it's open circle. That value doesn't count. So that means k of negative 1 is actually going to be down here at negative 1. So you just got to find where the graph is at those x values. So in 6, it tells us to find f to the negative 1 of 4 if f of x equals x over 2 minus 3. So remember, that negative 1 there means we need to use the inverse. I don't have the inverse yet. I have my original function. So what I have to do is I have to figure out what my inverse is first. So following our steps from last time, I'm going to first change it from f of x to be y equals. So then next I'm going to switch my x and my y. And now we'll solve for y. I'm going to add 3 first. I got x plus 3 equals y over 2. When you got y over 2, that means we're really dividing by 2. So the opposite of division would be to multiply by 2. And you got to remember to multiply everything by 2. I would get 2x plus 6 equals y. So I now have y by itself. I can go ahead and fix my notation. Put that back to my inverse notation. So that's f to the negative 1 of x equals 2x plus 6. So now that I have my inverse, now I can actually figure out what f to the negative 1 of 4 equals. Now I can plug in that 4. 2 times 4 gives us 8 plus 6 gives us 14. So the new thing is on the back, and it's what we call composition of functions. Now with our composition of functions, that means you have more than one function, and you have to take a value and you have to plug it in to the multiple functions. Generally it is just 2. I have occasionally seen where it's been more than just 2. So our notation for it, as I said, we have 2 different ways, is you've got this little funky open circle thing here. That's a little open circle. That's one way of writing our compositions. So what that stands for is you would do the g function after the f function. That little open circle kind of stands for that word after. So it's telling you which order to go in. So then our other way of writing it has a whole bunch of parentheses there. You got the g of f of x. So, to evaluate, you always start with the function closest to the input. So the input value could be an x. The input value could be a number. It could be asking you to change a letter around. I'm going to do the same thing over there for the other one. You're always going to evaluate the function closest to the input first. So here in this example, in this notation, our input there is the x. The function that's closest to it is the f function. So you would do the f of x function first. So you evaluate that, and then you take that answer and you plug it into the other one. You plug that into the g function. Same thing would happen over here with this notation. The f function is the closest one to your input value of x. So you plug it into there, and then you take that answer and you plug it into the g function. So you start closest to the input and you just kind of work your way out. So let's try some examples. So down here we have f of x is simply x squared. G of x is going to be the function x plus 1. So those are our 2 functions we're dealing with, f and g. So here they want us to find f of g of negative 4. So again, we start with the one closest to the input value first. So we're first going to figure out g of negative 4. So I plug my negative 4 in for x. What do we get when we do negative 4 plus 1? Negative 3. So now we're going to take that answer, and you're now going to plug it into the f function. So now we're going to do f of negative 3, which that's telling us to take that value and square it, because it's x squared for our f function. So what is negative 3 squared? There's your final answer. So f of g of negative 4 ends up equaling a 9. Let's try it again for the next one. So again, you're starting with the one closest to the input value, so we're going to start with the f function. We're going to do f of 3. So that's telling us to take 3 and square it, because they want us to take x and square it. So 3 squared gives us a 9. So now we have to take it and plug it into the g function. So we got to do g of 9. I'm going to take my 9, add 1 to it, because g function is x plus 1. So 9 plus 1. So we get a 10. So same thing, you're still evaluating. Just You're evaluating twice. So 3, we're changing our value around here. Or I'm sorry, we're changing our function around. We now have f of x is 2x plus 4. So they want us to do f of x after f to the negative 1 of x. Again, that negative 1 is telling me I need to find my inverse. So we got to first find the inverse of our function here. So y equals 2x plus 4. Switched it from f of x to y first. Switch my x and my y. And so now we solve for y. So I'm going to subtract the 4 first. So x minus 4 equals 2y. Divide by 2. So I'm just going to leave it as x minus 4 all over 2 equals f to the negative 1 of x. We now have our inverse function there. So our inverse is the one closest to our input value of 2. So that's the one we're going to start with. So f to the negative 1 of 2 equals 2 minus 4 all over 2. So what is 2 minus 4? Negative 2. Divide that by 2. Negative 1. So now I'm going to take that negative 1. I'm going to plug it now into my f function. So 2 times negative 1 gives us negative 2. Negative 2 plus 4 gives us positive 2. Does anybody notice anything about our final answer and what we started with? What was our original input value? The original input value was 2, and then our final answer was 2. Because what we did is we took a number, we plugged it into an inverse, and then we plugged it back into the original function. Whenever you do that, regardless of which order, you're always going to get back exactly what you started with. So any input plugged into a function and its inverse is your answer. I could have plugged in a 10 there, plugged it into the inverse, plugged it back into the original function, and I would have gotten 10 as my answer. I could have plugged a negative 7 in, plugged it into the inverse, plugged it into the function. I would have gotten negative 7 as my answer. So whatever your original input is, if you plug it into both the function and its inverse, you're always going to get that answer back. So if we take a look at number 4, we have h of x equals 5x minus 2. They want us to plug it into h of x and then into the inverse of h of x. So again, whenever it's the function and its inverse, we don't have to sit here and figure out what the inverse is like we did on the last one. 123 is getting plugged into both the original function and then its inverse. So that means our answer is 123. So you don't even have to do all the work for that. You can just remember that one little rule. Now it doesn't work. Let's say, for example, I had g to the negative 1 of f of x. It doesn't work in that instance because those aren't the same functions. It's not the inverse of f. It has to be the same function and its inverse, not a different one's inverse.